Oh wait, no, 383.
And
There we
that's
go.
in big ideas.
It's in the algebra 2 McDougall Little. Yeah.
Yeah, no, I thought that's what we were talking about, but I wasn't 100% sure. I remember what I have to do here too. I got to make sure that I'm at 100%. Otherwise, it has problems. Oops. Page what?
283.
Big jump. Skipping around. I think last time weren't we on 150 or something?
Oh, not 283. I mean 383. I'm so sorry.
Three.
Yeah, we moved on to our third unit, and once again, I don't know what I'm doing, and I don't know. My teacher, she's like, I kind of understand how she teaches, but I've had trouble with her all year, so
383.
yeah.
Okay, let's have a look at what we're looking at here. All right.
And then
I can straighten you out here. Let's see. Now I want to blow it up. This is really weird. I got to blow it up to magnify it, but if my browser is blown up to begin with, it doesn't let me find the page. So, adding rational fractions or subtracting rational fractions.
okay.
The sum or difference of the two rational expressions, then match the sum or difference with its domain. Explain your reasoning. Okay, what's the answer to A? Here, let me take a snapshot. So how do we
I
add
think we
those two?
have I think we have two different textbooks here. I have a completely different page than you.
Oh, can you read them to me? That might be the easiest
Yeah, I
way.
can do that.
Um, let me minimize that and open this. Go ahead. Once you go through a couple, you're going to understand it and you'll be able to.
Yeah, I that's usually how it is. I just like your way of teaching is a lot more understanding
Well,
or understandable to for me.
thank you.
Anyway,
I appreciate
so
it. Mhm.
my first problem I have to do is x to the fourth plus 2x to the third minus 4x squared plus x minus 10 equals 0.
Like that?
Equals 0. Yeah, that's right.
And you're supposed to solve for the zeros?
Identify the number of solutions or zeros. Yeah.
Okay. How many do you think we have?
Um, I honestly like I'm clueless right now.
It has to do
I
with that. In other words, this is a fourth degree polynomial.
Okay.
And it therefore has four solutions, which means four zeros. In other words,
Okay.
let's take a look at this problem here. X squared equals 25. That is a quadratic.
Okay.
Therefore, it has two solutions. So if I take the square root of both sides, I get plus and minus 5. So those are my two solutions. Now,
Okay.
occasionally you will have only one solution, but it'll have multiplicity of two. In other words, if I took this problem, this is also a quadratic.
Mm-hmm.
So if I multiply that out, it's x squared minus 6x plus 9. But you'll notice this only has one solution, but it has it twice. So we say the solution is x equals 3 with a multiplicity of 2. I'm sure you've talked about multiplicity in class, right?
Yeah, we
Okay,
have.
that's what it means. If I had x cubed times those two, well, x equals 0 is a solution with multiplicity of what?
3
Uh-huh.
or yeah.
Yeah, because what this means is x times x times x times x minus 3 times x minus 3 equals 0. So each of those x's can be 0. And then we would also have x equal 3 with multiplicity 2.
Okay.
And multiplicity is important in the sense that it tells you whether it's going to cross the axis or not. If you have an even multiplicity, it doesn't cross the 0, it touches it and goes back up. If you have an odd multiplicity, it crosses the x-axis always. By
Okay.
odd, I mean 1, 3, 5, whatever. But
Okay.
if you have multiplicities of 2, 4, 6, they're going to kiss the x-axis and go back up. So that's why multiplicity is very important.
Okay.
What else did they want with this problem? They surely don't want you to try to factor it.
It just says for on my homework it says identify the number of solutions or zeros for that problem.
Okay.
For 3A.
So
Yeah.
it's always the same as your degree polynomial. Your highest.
Okay.
Even if I had x to the fourth equals 0, it's 4 solutions, and it's 0 times 0 times 0 times 0. So it's a solution of 0 with multiplicity 4.
Okay, so I would write that as like x equals 0 to the multiplicity of 4.
Are you talking about over here?
Yeah.
Well, if they ask you about multiplicity, if they just ask you for the zeros, then it's all you have to say is x equals 0. So
Okay.
here it appears that there's only one answer. And there's only one unique answer over here, but it has multiplicity of 4. In other words, if you have a quartic, which is what this is, there's always going to be 4 solutions. If you have a cubic, there's going to be 3 solutions. If you start with a quadratic, it's going to be 2 solutions. If you start with a linear, let's just do this one right there. That's got one solution only, x equals 10.
Yeah. Okay.
What else do we got?
Uh. Okay. So we have 3, 5. Okay. 9t to the 6th minus 14t to the 3rd plus 4t minus 1 equals 0.
Same question.
Yeah.
How many solutions do we have?
Is it 1?
It's always the highest exponent you see.
Okay, so no matter what, it's
Mm-hmm.
the same as
Does
the
not matter if that could be 1400 t cubed or 14 million. The only thing that matters is that exponent right there. That's how many, and the biggest exponent. In other words, it's not this exponent that matters. It's the biggest one.
Okay.
So you have 6 solutions. That's simple.
Okay. The next
Now,
one.
don't confuse that with being able to figure them out. I don't know how to figure out this problem right now. In other words, figuring out the 6 solutions is beyond what you learn in precalculus or even calculus. You pretty much have to feed that into a calculator and it'll give you 6 solutions.
Okay.
Okay? Anything above a quadratic becomes extremely difficult to actually solve for the zeros.
Yeah.
Amazingly difficult. Who knew? But it's true.
Okay. All right. Number 9 I can do on my own. So.
Yeah,
Number 21 is what I'm gonna skip to because it's a different type.
yep.
Okay. Write a polynomial function of least degree that has rational coefficients and then leading coefficient of 1 and the given zeros.
What are the zeros?
So we have -2, 1, and 3.
Okay. What kind of polynomial are we looking at? What degree?
What degree?
Uh-huh.
Zero. There's no degree.
How many zeros do we have?
Oh, 3.
What degree?
So it would be a 3 degree, right?
A third degree polynomial.
A third degree. Okay.
Uh-huh. Now, by giving us the zeros, it's actually telling us what the linear factors of that polynomial are.
Okay.
Now, let's go back a step. We're doing something backwards here. If I have this, tell me the zeros.
So the zeros are -2 and +3.
No, you set each thing to 0. In other words, I set x minus 2 to 0 and solve for it. So the 0 is 2, and I set x plus 3 equal to 0 and solve for it. The other 0 is -3.
Okay.
So if given the 0, you can figure out that that's the linear factor. If given this 0, I can figure out that that's the linear factor.
Okay.
So there are 3 linear factors over here. What are they?
No. 2 and then
X plus
-3.
2. You need the x. This is a linear factor. That's just an x value.
Okay.
So to convert the 0 to a linear factor, you got to go backwards. Okay? What's the second linear factor?
X minus 3.
Well, let's do them in order. X minus 1. And the third
X.
one is x minus 3.
Okay.
Okay? Now, there is a polynomial with those zeros. So all I have to do is multiply it out. So let's do this the easiest way, which is to multiply this times this first. And I'll explain in a second.
So -1 times -3.
No. Multiply x minus 1 times x minus 3.
Okay. X plus 1 and x minus 3. That's x squared.
Foil it.
Okay. X times x is x squared.
Hold on a second. I didn't do this right. Let me scroll down a little bit here so I have a little more room. Fortunately, my eraser isn't working on this thing. So what is x minus 1 times x minus 3?
X squared.
Okay.
And then 3. X squared plus 3.
Nope. You got to foil it. You can't make the most common mistake that people make in algebra, which is just to square the first term and multiply the last term. That's not how you do it. You multiply first terms, then you multiply outside terms, then you multiply inside terms, and then you multiply the last term. That's what FOIL stands for.
Okay, so
You
x
do all of that, you get x squared minus 3x. Keep going.
squared minus 3x, and then x, or no, minus 1x, and then plus 3.
Plus, exactly. Okay, now I can always combine those two middle terms. So I end up with x squared minus 4x plus 3. That's what x minus 1 times x minus 3 is. Now I got to multiply that by this x plus 2 still. Now, FOIL doesn't work when you're multiplying a binomial term times a trinomial term. There's an F, but there's no O, I, or L. Okay? So what you got to do is basically the same idea, but I call it ET. To me, that's what FOIL should be called.
Every term by every term.
Every term by every term. So,
Okay.
what do you get?
Well, I gotta do x times x squared.
Right.
So that would
Always
be,
start from the left, do all the x's, and then go to the next term, the 2, and do all the 2's.
okay. So x times x squared is x to the cubed, and then x times negative 4x is negative 4x squared, and then that's all my x's, so I gotta go to the
Oh,
2.
there's one more x.
Oh yeah, okay. X times 3 is 3x.
You need the plus sign.
Plus 3x.
Okay, keep going.
And then now I switch the 2.
Right, now you do all the 2's. Every term by every term.
Okay, so 2 times x to the squared. Or no.
You need a sign in front of it. This is not a case where you can ignore the plus or the minus. If I write 2x squared, that expression has no meaning because there's no sign between the 3x and the 2x squared. I need a plus sign there.
Yeah.
I am writing a polynomial. You cannot infer the plus sign. You have to state it or write it. The only plus sign I don't need to write is the one in front of the first term, the x cubed. If I don't write a plus sign there, it is inferred. But all these other terms need a sign in front of them. Keep going on the 2.
So 2 times negative 4x is negative 8x. So
And finally,
6 plus 6.
okay, now there's always simplification that can be done here. And it's always on the inside terms. You're not going to find any other x cubes, and you're not going to find any other plus 6. But we've got a couple of x squared terms, and we've got a couple of x terms. So let's simplify this.
Okay, so
what are total x squareds?
We have 1x squared.
We're combining that and that.
Okay. Wait, I thought that didn't have a square on it though, with the 2.
The 2 doesn't have a square. What we're combining are the x squareds. Think of x squared as an apple. We got minus 4 apples plus 2 apples. How many apples do we got?
2. No, we have negative 2 apples. So.
Negative 2 apples, and apples are x squareds. So that takes care of that term and that term. Now let's deal with the x's. How many x's do we have net?
3x and negative 8x.
Combine them.
Negative 5x.
And we still have this plus 6 over here. So what we have is a polynomial whose zeros we know, because we created this polynomial using the 3 zeros they gave us.
Okay.
Okay. Now, they had a couple of other conditions. They said the coefficient needs to be 1 in front of the x, the highest degree, I believe. And they said you had to have all rational coefficients.
Okay.
And we do.
Yeah, we do.
That expression will, if I were to set that equal to 0 and solve it the hard way, the 20-minute way, I would discover 3 zeros. And they would be -2, 1, and 3. I think that was the original zeros, wasn't it?
Yes, it was. -2, 1, and 3.
Yeah. So that's how you do it. If they give you the zeros, the very first thing you got to come up with is those linear factors. So let me just test you again. Here's the zeros. -7, 2, and 6. Tell me the 3 linear factors.
X -7.
No.
And then what?
Always the opposite sign.
Okay, X +7.
Yeah.
And
And notice why.
-6.
Before we go on, notice why. I'm going to solve this equation by setting x plus 7 equal to 0, and that gives you x equal -7. So that's why they're always opposite signs. So what's this?
Okay, that makes sense then. That one is X -2.
Okay, and this one?
X -6.
Correct. Okay. Now, let's say the question said, come up with a polynomial with these 3 zeros that has a leading coefficient of 2.
Okay.
Well, let's say I came up with an answer like this. I don't want to spend the time going through that whole multiplication again, but let's just say this was my answer. Okay? Well, that certainly is a third-degree polynomial with these 3 zeros, but it doesn't have a coefficient of 2. It's got a coefficient of 1. So what can I do?
You can.
Notice that if I express that like that, which is correct, I can multiply both sides by 2. And when I multiply both sides by 2, I get this. And when I multiply 0 by 2, it stays 0. So there you go. There is a polynomial that has the same zeros as the one above it. Because if I was given the one with the coefficient of 2, I could just divide all sides by 2 and get back to this one. So this is a different function, but it's got the same zeros. So when they give you zeros, for example, there's a function that's got 3 zeros, okay? Right there, and right there. Well, I can actually draw a different function that has the same 3 zeros. Notice.
Yeah, I know.
So it's not just one function that has those zeros. There is an infinite number of them. In fact, you can take this polynomial that we got and multiply by any number you want. Every one of them is a different function, but every one of them will have the same 3 zeros. So zeros are the critical thing about most functions. You want to know where it crosses the x-axis.
Yeah. Okay. I only have like 11 more problems to do, but I have a pretty good understanding.
Okay. So. I can give you an extra 5 minutes because we started 10 minutes late.
Oh, that'd be sweet.
Yeah. Go ahead and we'll go for another 5 minutes.
Okay. The next one. Oh, okay.
Incidentally,
It's
I can only do that because I don't have a 6:30. If I
yeah,
had a 6:30, I would not be able to offer that. If
yeah,
you're 10 minutes late, we're only going to do a 20-minute session. But
yeah.
if
I
I don't
understand.
have a session following it, then I don't mind doing
Okay, this is a this one's a lot harder with
it. Okay?
the zeros. So the first zero is 4, the second one is -5 squared, and then the
Negative
third
5
zero.
squared like that.
Oh no, the
Oh, you
square
do
root of
negative
5.
5
My
with
bad.
multiplicity of 2.
No, I'm sorry. It's the negative square root of 5. My bad.
Oh, it's this.
Yeah, sorry. I
Okay,
had
that's
trouble
all
verbalizing that.
right. Okay.
And then the
One of the things that's good about online tutoring is that you get practice in verbalizing it, and that solidifies understanding. It does.
yeah,
It's a good thing to have to learn how to verbalize this stuff. And you
okay,
don't
and
get any
then
chance in class. I doubt that you ever stand up in class and verbalize a problem.
no, I
So
never do.
this is good education for you.
Okay. And then the third term is the square root of 5, +5. This one.
Okay. So the first one,
So,
square root of -5 or negative square root of 5?
uh, for the first one, we're gonna get the negative. No,
I think it's
we're gonna get the pop.
I think it's what I've written here. Correct or not? Is that what your problem shows?
Oh yeah, yeah, that is.
That's all I need to know. So tell me my 3 linear factors. This looks harder, but it's not.
Okay, so your first factor is x -4, and then your second factor is x plus the square root of 5,
Correct?
and then the third one is x minus the square root of 5.
Correct. Now, in this particular case, it really makes sense to multiply these two together first. Obviously, I could do this times that and then take the result and multiply it by that. In other words, I've got A times B times C. I can do it in whatever order I want.
Okay.
Okay. Now, the reason I definitely want to do the right two first is because they turn into x squared minus 5. That is the difference of squares factored.
Okay.
I happen to know that x squared minus 5 factors into x minus square root of 5 times x plus square root of 5. It works exactly like difference of perfect squares, only this is not perfect squares. But guess what? It doesn't have to be the difference of perfect squares. It really is the difference of squares. So even when you have a number that's not a perfect square, you can still factor it the same way you would factor a difference of perfect squares. So whenever you notice this and its conjugate, know that when you multiply those together, you're not going to have any middle terms. You're only going to have the two end terms, and they're going to be subtracted.
Okay.
Okay? And now I can use FOIL. In other words, FOIL is no different than ET, but the fact is I'm multiplying a binomial times a binomial.
Okay,
Always
so
easier. So let's do it.
first term by first term. So x times x squared is x cubed.
Yeah, and ET works for this also. In other words, ET replaces FOIL. You don't need FOIL ever if you always remember ET.
Oh, okay. So, and then first by outside. So x times -5 is -5x.
Okay,
And then -4 times x squared is -4x squared. And then -4 times -5 is +20.
okay. Now notice you can't combine anything. But what should we do? That's not really a proper answer.
We
Put it in order of the powers of x.
okay. So x cubed minus 4x squared minus 5x plus 20.
You got it.
All right.
Now, when these two multiply together and give you a trinomial, like the other time, like
Okay.
an earlier problem,
Yeah. Yeah.
I still like multiplying those two together first. And the reason is to me, I would rather multiply binomial by trinomial. I would rather do this than this. I don't know why, just a personal preference. They're both the same. And you would do both the same exact way. Every term by every term.
I guess it would be.
I'm more comfortable with the binomial as the first term.
Yeah, I could see it being in like descending order, or I mean, like rising order.
Yeah.
But
It makes it easier because you can do that times that, and then you can do that times that, and you can do that times that. And then you only have one other thing left. That times that times that, and that times that. Same thing down below. It's just you would do this, and then that, and then you do it that, and then that, and then you would do this and that. It's always every term by every term.
all right.
Okay?
All right.
All right, Britt, I'm going to let you go. You have a...
Alrighty, thank you for the session.
And, yeah, I'll probably work.
I'll see you next week.
Bye-bye.
All right. Bye-bye. Have a good night.
You too.